In this video, we're going to be talking about molecular formulas. In order to be successful with molecular formulas, you have to know how to do empirical formulas. That would have been the lesson previous to this one. So if you didn't catch empirical formulas, please go back and do that before you try to learn molecular formulas. With empirical formulas, we learned that an empirical formula is the lowest whole number ratio of atoms in a compound. A molecular formula then would be some multiple of that empirical formula. In the definition we have here, it says it's also known as a true formula, and again, it's going to be some multiple of an empirical formula. I'd like to give you some examples of empirical and molecular formulas. So let's consider a few molecules. How about we look at H2O, H2O2, C3H8, C4H8, N2O5, and C6H12. So we have 6 molecules written there. I want you to take a look at that list and see if you can figure out which one of those molecules or which ones of those molecules are empirical formulas. What you would look for are formulas that you can't reduce. They're already in the lowest whole number ratio. I'll give you a minute to look over that list. Okay, so if you're looking for empirical formulas, hopefully you would have labeled H2O as an empirical formula. I'm just going to put a red E there to note that it's an empirical formula. You would have also said that C3H8 is an empirical formula because that's already in its lowest whole number ratio, 3 carbons to 8 hydrogens. And you would also say that N2O5 is an empirical formula because it cannot be reduced. That means that the other 3 are molecular formulas or some multiple of an empirical formula. If you look at H2O2, you can cut that in half and reduce that to HO. So HO would be the empirical formula. And we would say that H2O2 is 2 times bigger than HO. For C4H8, we could reduce that one down to CH2. And if we compare those two, CH2 to C4H8, we would say that that one is 4 times bigger. The C4H8 is 4 times bigger than the CH2. If you take a look at the C6H12, the empirical formula for C6H12 would also be CH2. And this one, if you compare the two, CH2 and C6H12, this one would be 6 times bigger. So when we're comparing empirical and molecular formulas, the empirical is the lowest whole number ratio. It's reduced. You can't simplify it anymore. The molecular formula is some multiple of that. Now, to figure out what the molecular formula would be, we have a little formula that you can use. So let me change my pen color here. What you would do, we say X equals the molar mass of the molecular formula divided by the molar mass of the empirical formula. Okay. So what's going to happen is you're going to take the molar mass of the molecular formula and put that on top. So in this example, that would be the molar mass of H2O2 divided by the molar mass of the empirical formula, in this case HO, and what this X is going to give you is how many times bigger to make the molecular formula than the empirical formula. Because it makes sense, if this is twice as big, it would have 2 times the molar mass that the empirical formula does. So that's all we're getting when we look at this X here. We're dividing the molecular formula's mass by the empirical formula's mass to find out how many times bigger to make it. This X is always going to come out to a whole number or something very, very close to a whole number. If it doesn't, you want to go back and double check your math because it means you probably did something wrong. The other thing I want to point out to you is that this number on the top is always given. Okay, so the molar mass of the molecular formula is always given in the problem. The molar mass of the empirical formula is something that you're going to have to find. So let's take a look at some example problems. Okay, the first one says, find the molecular formula of P2O5 if it has a mass of 283.899 grams per mole. So in this case, you can see in the problem that we are given the empirical formula, P2O5. The problem asks for the molecular formula, and it gives us this molar mass that I said would be provided in every problem. So we are going to do our x equals. And we said we were going to do the molar mass of the molecular formula divided by the molar mass of the empirical formula. So when we plug those numbers in, this 283.899 grams per mole is going to go on the top. And then what you're going to have to do is get your calculator out, figure out the molar mass of the P2O5, and that's what's going to go on the bottom here. So I'm going to add up the molar mass of P2O5. I'm going to look at my periodic table, 2 phosphorus atoms and 5 oxygen atoms. And that comes out to 141.943. And even without a calculator at this point, if you look at 283.8 divided by 141.93, that's going to come out to roughly 2. If you do the math, you get 2.0000915, so you can see that that is roughly 2. So like I said, this is going to come out to a whole number, or something very close to a whole number. And what that tells us to do now is take this P2O5 and make it 2 times bigger. So I'm going to take P2O5, I'm going to make it 2 times bigger because that's what that 2 tells me to do. And my answer is going to be P4O10. And that is my molecular formula. So when the problem says find the molecular formula, it gave me the empirical formula. I looked up that molar mass and put it down here. This molar mass was given in the problem. Got the whole number 2, made the empirical formula twice as big. There's my answer. I have another example for you. This problem is a little bit different because it says the molecular mass of nicotine is 162.1 grams per mole and it contains. Notice in this one, it doesn't give us the empirical formula, but it gives us the percents that we can use to find the empirical formula. So this is an empirical formula and a molecular formula combined together in one. We're first going to have to find the empirical formula and then use that information to find the molecular formula. This makes a great question on a test that would be like a part A and B. So part A might say find the empirical formula for nicotine and give you this information. And then part B might say if the molecular mass of nicotine is 162.1, what's the molecular formula? We're going to do it all as one problem here. So I'm going to start the empirical formula. 74.0 grams of carbon, and I have 8.7 grams of hydrogen and 17.3 grams of nitrogen. So I'm going to do my gram to mole conversions just like you did yesterday. And you're going to look up these molar masses on the periodic table. Don't worry if the decimal places aren't exactly the same as the ones I'm writing here. As long as your numbers pretty much match, you're in good shape. You can pause this video if you need to catch up, if you're writing down this work as you go. So for this one I get 6.16 moles of carbon. .63 moles of hydrogen, and then 1.24 moles of nitrogen. Now don't forget this step where you divide each by the smallest. Okay, this is a step that people often overlook, so notice I didn't really round yet. So I'm going to divide each by, what's my smallest? This 1.24. All right, so this one's going to come out to 1. This one is going to come out to 5. And this one is going to come out to roughly, let's see, 6.95. That's going to round up to 7. So I'm just double checking my math here to make sure I have this correct before we move on. All right, so my empirical formula then would be C5H7N. Now I'm at the point where I started the last problem. I have my empirical formula and I have the molar mass of the molecular formula. So I can do my x equals equation. Let me get a different color pen. So we'll do x equals the molar mass of the molecular formula on the top, 162.1 grams per mole. I'm going to do the molar mass of the empirical formula on the bottom, so I'm going to have to add that up and put it on the bottom. And that comes out to 81.12 grams per mole. So if you look at that math, 162 divided by 81 is going to be 2. So this is another one in which we're going to make this empirical formula twice as big. So instead of C5H7N, I'm going to double it and make it C10H14N2. Let me just make sure I did that right. Okay, double that, and then this is going to be my answer. Notice the molecular formula is 2 times bigger than my empirical formula up here. Now this number is not always going to come out to this number is not always going to come out to 2. It was just a coincidence in these examples, but you can have anything from 2, 3, 4, 5. Sometimes it'll be 1. If it's 1, you just keep it the same. And that's all for molecular formulas. Good luck with your practice. Let me know if you have any questions.